So yesterday we talked about if we have two lines that are parallel, what's this line called that crosses them?
It's like the
Inversal or something.
No.
Transversal.
Transversal. Okay, the transversal crosses those two lines. How many angles are created?
8, yeah.
8 angles. Okay, so there's a group of 4, a group of 4. If the lines are parallel, what do I know about angles 1 and angle 5?
They're the same.
They're the same, and they are called what?
Converse.
Yeah. No,
Correlating.
Corresponding angles. Kind of like correlating, but don't get that word in your head because I'll get mixed up.
Well, now it's in my head.
Corresponding angles are congruent. That is a postulate, but if you just need to reference it, you can just say corresponding angles are congruent. The full thing is corresponding angles are congruent if the lines are parallel. Because if the lines aren't parallel, they're not going to be congruent, right?
Yeah.
If they're like this, these are not the same angles. Okay, anyway, corresponding angles are congruent. How about 3 and 6?
Interior angles.
They're interior, but they're also on different sides of the transversal, so they are.
Alternative.
Alternate
Interior.
interior. And those are also congruent, right? Okay, and then we also did about like 8 and 1. Alternate exterior angles. And what do we know about those angles if the lines are parallel?
But they're the same too.
Alright, so we got congruent. Whoops. And then what am I missing? Do you guys remember?
Like the one that doesn't.
It's 4, yeah, 6 and 4.
6 and 4, or 3 and 5. 6 and 4 are called.
Consecutive.
Interior. They're called interior because they're between the parallel lines. And what do we know about consecutive interior
They're
angles?
supplement.
Right. So they're not the same. This is acute, this is obtuse. They're not the same, but they do add up to 180, so they are supplementary. Okay, so yesterday, those are the 4 things from yesterday. If the lines are parallel, all 4 of these things are true. What?
Can you scroll up a bit? Because what if, like 8 and 2, is that just exterior? Is that interior?
Okay, not all of these pairs have a name. So 8 and 2, there is no special name. But you can just tell by looking, that's an acute, that's an obtuse, so they would have to be supplementary. Because remember, all of them were either supplementary or, like 8 is supplementary to 7, right?
Yeah.
They're a linear pair, and 7 and 2 are the same.
Mm-hmm.
So 2 and 8 are supplementary. But they didn't give them a special name or a special theorem or anything, so only those 4. I don't know why they chose not to do every pair, but whatever. Those are the 4 theories.
Hey, it helps us study it. It's less for us to memorize.
That's true. It's less things to worry about. Okay, so yesterday we talked about if the lines are parallel, all 4 of these things are true. Today we're going to talk about how do I know, can I prove whether the lines are parallel or not? So the way we prove the lines are parallel is kind of these same 4 things plus a couple others. So, for example, here. Let's say this is my picture and I've got a, 125 and a 125. Okay, are these 2 lines parallel?
Yes.
Yes, because why?
They equal 180.
Because the corresponding angles are congruent.
Determine that, yeah.
Okay, if the corresponding angles are congruent, that only happens when the lines are parallel. Okay, Or if you have 125 and 55, are these two lines parallel? Yes, because
That was that.
consecutive interior angles are supplementary. So yeah, that does work. So we're kind of reusing all these same things. Or are the lines parallel now? Yes, because alternate interior angles are congruent. Or now? Yeah. Yes, because alternate exterior angles are congruent. Okay. Something that would be a no or not congruent is if I had like this picture and let's say this was like 70 and 70 or something like that. Are these lines parallel? No, why not? Okay, these two shouldn't be congruent. Okay, they should add up to 180. So if they're 70 and 70, they're gonna intersect over here somewhere, right? It's not gonna work. But yeah. Okay, kind of one thing that is new today that we're gonna add on is another way to prove lines are parallel is if they are perpendicular to the same line. What does perpendicular mean?
Up and down,
Means
or like up and side.
two lines that intersect at a 90-degree angle, at a right angle, are called perpendicular. So you could say line A is perpendicular to line C. And if line B is perpendicular to line C, then these two angles would have to be parallel. Think about it, makes sense. Kind of like a ladder. Like if they're 90 degrees and 90 degrees, these two would have to be parallel. Okay, so that's another way you know lines are parallel. Did I skip one? I think that might have been it, actually. Oh, yeah, I did skip one. This one, not as useful, but, okay. It's kind of like the transitive, they do call it the transitive property. If A is parallel to B and B is parallel to C, then guess what?
They're all parallel.
A is parallel to C. So, we didn't really talk about this yesterday, but, like, 1 corresponds to angle 2, corresponds to angle 3. So 1 and 3 you could also say are like corresponding angles. Or, yeah, anyway. So you could have like multiple, you could have as many parallel lines. That's possible. Okay, one of the hard things today is that the pictures look different. So, do you guys know what this shape is called, if I drew it right?
Or wrong.
Yeah. Yeah, it's called parallelogram.
Yeah.
Because we're gonna have like a whole chapter on these, but it's because the opposite sides are parallel. Those two are parallel, and these two are parallel. Parallelogram. Okay. Well, what do you think we might know about like this angle and this angle?
They're the same.
No, they're not.
They're not the same.
Okay, let me show you a picture here. Actually, let's do a different color. Okay, if these two lines are parallel, what do I know about these two angles?
Oh, they're supplementary.
They add up to 180. Okay, do you see it?
Yeah.
So these two angles are,
Supplementary.
yeah, they're consecutive interior. That's, okay. What do I know about this angle and this angle? Same thing. It's just if you turn your head, it looks the same. So it's like, whoop, this is the transversal. These are the two parallel lines, and these are same side interior. So they have to be supplementary. Which means, this gets into a later chapter, that these two would have to be the same. And these two would have to be the same. But yeah, we got some weird pictures. Here's another weird picture. Let's see, like, I don't know, whatever, 60 and 60. So, in this picture, so there's kind of some extra lines that might be confusing, but basically what's happening is, I didn't draw this very well. It's a little bit better. What's happening is we've got a couple 60s right here, right? So what kind of angles are these?
Congruent. Well, they're
If they're the twin angles in this pair of four, this group of four, and they're the matching angle, that's called
corresponding.
corresponding. So, I don't know if you guys can see it, but these are basically the same thing. You guys get it? I kind of lost my picture there, but like that goes there and these go here. So those are corresponding angles. Like this is the transversal. These are the two lines coming down. Okay, so those two angles are the same. That means these two lines would have to be parallel. Corresponding angles are congruent. Okay, so the pictures are kind of weird, but we'll figure it out. Okay, number one. Which segments can be proved parallel? So number one kind of looks like my picture that I just drew, except for it's upside down. They put 52 right there and there. So if I eliminate all the lines that do not make those angles, I can get rid of that, get rid of that. Okay, what kind of angles are these?
Corresponding.
They're corresponding angles. So which lines must be parallel? That'd be these two. Now these two lines over here, they look parallel, but we don't know that they are, right?
Yeah.
But if these two angles are the same, we know these two lines are parallel. So it's what line? What are the lines called on number one?
A parallel with B.
No, A is not a line.
I mean,
A, E. If you put line, I would take it, but they put line segment. Segment AE is parallel to BD. And we were supposed to give the reason. Okay, it's technically it's like corresponding angle postulate, but I'm just gonna have you guys say corresponding angles are congruent. Therefore, those lines have to be parallel. But we'll just say that. Okay, let's go and look at number two, because this one's tricky also. Kind of a parallelogram, but it's got the diagonals drawn in there. So we got 62 and 62. So kind of my best advice is, what if I just drew those angles, just the lines that made those angles, what would it look like? And it would look like this. 62, 62. So what kind of angles are these?
Acute.
Not what I'm going for.
congruent.
Are they corresponding?
Yeah, corresponding.
No.
Or not?
Transversal.
No, that's not one of
They're
those.
alternative interior.
They're alternate because they're on alternate sides of the transversal. They're interior because they're between these two lines, which are going to have to be parallel. So alternate interior angles. So which lines are parallel? It would have to be these two. This one is a transversal. So what are these two?
ZW and YX.
Right, ZW and YX. Because the alternate interior angles are congruent.
Because what?
What kind of?
Alternate interior angles are congruent.
Yeah.
What?
So what was it? So it was ZW.
ZW is congruent to YX.
Parallel.
I mean, yeah, parallel. And its alternate interior, or ultimate interior angles are congruent.
Okay, we kind of talked about this one for number 3. How are these two angles related? X and 180 minus X.
They're supplementary.
Yeah, remember when we solved supplementary angles, we always, if we know one of the angles is like 50, the other one's gotta be like 180 minus 50.
Yeah.
So these two are supplementary. What kind of angles are they? You guys see it? No, that's not what I'm going for.
Oh, wait, don't say. Oh, it's the one where they're like, they're like, I don't know what it's called. Something supplementary. Oh, corresponding.
They're not corresponding. Corresponding means the same, like the twin. So this one would be a
Consecutive.
twin with this one. Yeah, the consecutive interior. Consecutive just means in a row, like they're next to each other. Consecutive interior. So what lines would have to be parallel? That would be these two, like these two. This is the transversal, but these are the parallel lines. So that would be lines QT and RS. Because, whoa, there's a letter.
Consecutive angles.
Consecutive interior angles
They aren't congruent, but they're
are
supplementary.
supplementary.
I literally love this so much. Whoa.
All right, so number 5, 4 through 7, these look a lot like number 2. Very similar. So, which conclusion can be made from each statement? These are matching. So on number 5, they're saying angle 2 and angle 6 are congruent. So if I just drew the lines that create those angles, what would it look like? Backwards Z, right? You guys see where I got that from? I'm trying to get rid of the extra lines so it's less confusing. So, and if I extend this one, it probably looks even a little more clear. Extend that. Okay, if these two, you guys know what kind of angles these are?
Alternate interior.
They're alternate interior. If these two are congruent, what lines must be parallel?
A, B, and
These two,
B,
the
C.
two lines are between, right? So, yeah, it would be the top and the bottom. Which option is line AB is parallel to DC?
A.
So, anyway, 5 is
I have a question.
A.
Is it ultimate or alternate?
Alternate.
Alternate.
Alternate means like the other one, like you switch. So, like alternate means to switch some things.
Okay.
So it means switch what side of the line you're on. We don't have to say alternate interior on this one though. Number 7 says angle 3 and angle 7 are congruent. If I drew that, angle 3 is up here and angle 7 is right there. So if those were congruent, what lines would have to be parallel?
AD and BC.
Okay, the top and bottom again. Okay, these two are not even part of the angles, right?
Yeah.
These two lines. And then it also says 2 and 6 are congruent again. So what angles or what lines would have to be parallel in that case? Bottom and top.
Yeah.
So it's bottom and top, bottom. So both of these are just saying the bottom and top are parallel again. So it's A again. Okay. Before we jump into number 9, I'm going to chat a little bit about it. Let's see, it goes 1, 2, 3, 4. Okay. Now, let's say that I knew angle 9 and angle 5 was the same. Would I know any lines that are angle 5 and angle 9 corresponding angles? I guess that's what I'm asking. Okay, it looks like they are, but they're actually not. Why are they not? Okay, because there is no transversal, a common line that's creating angle 5 and angle 9, they're actually not corresponding. Okay, so if 5 and 9 are the same, I don't really know anything about anything. But if 1 and 9, those are corresponding. Or
Wait.
1 and 5 are corresponding, but not 5 and 9. It's because there's no line between them.
Okay.
So
So
those
5 and 13 corresponding?
5 and 13 are corresponding, 13 and 9 are corresponding, yeah. Yeah, just 9 and 5 doesn't work. So they're gonna ask that on one of these evens, and you're supposed to say none is the answer. Okay, anyways, on number 9, the directions are which lines can be proved parallel for each given statement. Name the postulate theorem, that'd be like corresponding angles are congruent, that kind of thing. That justifies the answer. Write none if there's not enough information to prove the lines parallel. Okay, the first one says, number 9 says angle 7 and angle 15. Okay, that's there and there. So if those are the same, what lines must be parallel?
A and A and B. Yes, A and B.
Okay. Yeah, they're created by lines C and D and the transversal A, right?
Ah.
So it's lines C is parallel to line D. Because why? What kind of angles are those?
Corresponding angles.
Corresponding angles are congruent.
Oh, dang it, we're on the wrong one. We should switch these numbers.
Maybe I should have made my list over here. That's probably easier. Too late. It won't show up on the video. So we have, here's our word bank, corresponding angles. Alternate interior. Alternate exterior. And the one we can never remember.
Consecutive. I
Yeah.
remember.
Some books call it same side interior, which would probably be easier to remember. All right. Number 11. Says angle 1 and angle 12. So angle 1 and angle 12. What kind of angles are these?
Cool. Supplementary. Oh, they are.
Are they corresponding?
No.
No. Are they consecutive interior?
No.
No.
They're alternate.
Okay, they're nothing. Now, we do know, even though it's not one of our theorems, we did know that they should be supplementary. But if the lines are parallel. But they said they're congruent. Should they be congruent? No. Not normally. So we don't have enough information to figure out that these lines are parallel. So this one is none. They're not corresponding, they're not alternate interior, they're none of the above, so. "13, 12 and 15 are supplementary." Okay, should 12 and 15 be supplementary if the lines are parallel? kind of angles are these?
These are a consecutive
They're
interior.
consecutive interiors. Should they be supplementary at the
Yeah.
angles? Yes.
Yes.
So they are supplementary. That means what lines must be parallel?
A and B.
Right. They're created by lines A and B with the transversal of D. So these two lines must be parallel. A is parallel to B.
Do you have to put the postulate?
Oh yeah, I forgot. You're right.
Consecutive interior angles are supplementary.
You have a strong aversion to writing sentences. Okay, and then 15, last one of these is angle 5 and 15. Okay, 5 and 15. What kind of angles are these?
Alternate exterior.
Are they supposed to be congruent?
No.
Mm.
Yes.
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 All of these are supposed to be congruent.
Oh yeah, except for the very
Except
last
for
one.
this one, it's supposed to be supplementary. So yeah, what lines are gonna be parallel, the lines that create them, and the transversal. So that would be lines C and D. Line C is parallel to D because Alright, and then our last picture is a door. Alright, A, B, C, D, E, F, G.
I see what they're trying to do. They're trying to make it seem like
Okay, in the directions, it says that AB, what's that symbol mean? AB is perpendicular to BG. What is AB is perpendicular to BG? What does that mean?
That AB intersects, or like has a right angle from BC or BG.
Right. They intersect at a 90-degree angle. So AB and BG are these two lines. So they're telling us this is a 90-degree angle. It also says, what was the other one? CE and BG. So CE and BG. So that's these two. That's also 90. Now, if these two angles are 90, what should I know?
That it's supplementary.
Okay. If two angles are, or two lines are perpendicular to the
yeah.
same line, they have to be parallel.
Yeah.
Now, this is a door, so if the lines weren't parallel, you got a broken door, basically. It also says angle GFC and ECA are the same. So GFC, this one, and ECA. So if these lines or angles are equal, what kind of angles are these?
Corresponding.
Corresponding, yeah. If the corresponding angles right there, then these two lines are parallel. So really all three of those lines are parallel, as you would expect. Okay, so first question is 17. What is the measurement of angle ABE? Angle ABE?
90.
90, because they told us it was perpendicular, so that's 90 degrees. how do we know that segment AB is parallel to segment CE? Okay, we kind of already talked about it. How did I say we know that these two are parallel?
Because it says that AB is perpendicular to
Yeah.
EC.
Yeah, one of the new theorems is that if two lines are perpendicular to the same line, they're parallel. So they're both perpendicular to this line. So
Yeah, but there, isn't it AR?
that will count it wrong.
Like, for real?
I don't know. Let me try and find out.
I'm trying to,
You're such a rebel.
yeah.
Does that theorem have a name, like the one you talked about earlier?
Yeah, they did name it. We called it the no, that's the other one. Something about perpendicular lines. Converse of the perpendicular transversal theorem. So, probably just better to remember what it says rather than what it's called. Two lines are perpendicular to the same line, they have to be parallel. Okay, 21. Name three angles that are congruent to angle BAD. So angle BAD, angle bad is right there. We're supposed to find three angles that have to be the same as that one.
FGA.
Okay, FGA, because those are alternate interior between parallel lines. Okay, let me write that down. Angle FGA.
FAG. Wait, no. Is it the same thing?
Okay, somebody besides your own, another one.
Is CDG one?
CDG, this one right here. Okay, do they look the same?
No.
No.
That's not
Now, you can't really go by looks, but that's kind of a pretty big hint that they're not the same. FGD, FGD, we already did that one. Okay. That's the same thing as FGA. I could have called it FGD. EGD, EGD, this one right here? No.
Is CDA,
Oh boy.
maybe?
CDA.
Did I get one?
Are those the same?
Yeah.
They're alternate interior between these two, right?
Yeah.
Yeah, you got one.
Well, I'm so smart. None of you guys got that.
You're still not getting any credit because you used a conjunction on them.
Oh, yeah, sorry.
Or what's it called? Contraction. That's the word.
Can I say the last one?
No, somebody besides your own.
I know.
EDG. Because it is corresponding to this angle, yeah. Or it's vertical to that angle. EDG.
Wait, would also FA.
No, those are the only three.
FAG?
FA, nope. It would, no. Paxton. Sounded kind of
wasn't me.
like a donkey.
Oh, this?
That's you.
It's my nose every time I breathe out.
No.
I didn't hear it.
Paxton had a habit of like breathing through his pen cap and making noises. Sounded kind of like that. All right, 23.
Oh, it's Whitley's favorite.
None of this is like.
Okay, we're supposed to prove the alternate interior angles make the lines parallel. So we're trying to prove the lines are parallel. Starting with angle 2 is congruent to angle 7. How did they know angle 2 is congruent to angle 7?
Given.
Yeah, because that's what they told us, so that's what, basically why. Yeah, it's given. So we're starting by assuming the alternate interior angles are congruent. That's the given, and we're supposed to prove that the lines are parallel to show that. Now, we've been using alternate interior angles to make the lines parallel, but we're supposed to prove that it's true. That's what's happening. So, line 2 says angle 7 is congruent to angle 4. How did they know that?
That's vertical.
You have to look in the picture.
Alternate.
7, no, not
Is it
7.
corresponding angles?
No,
Consecutive.
no, vertical angles. Look at the picture.
Oh, oops.
7 and 4, they're right across from each other. They're vertical angles. Has nothing to do with parallel lines. Okay, without even looking at the book, look what we've written so far. Angle 2 is congruent to 7, 7 is congruent to 4, 2 is congruent to 4. That's probably what's coming next. Did they write that?
Yeah, well, no, they didn't
No,
write
that's
it.
a blank. So angle 2 is congruent to angle 4 because what property do we just use?
Transitivity.
Which
Transitivity,
they already wrote that, so I guess you don't have to write it.
property of congruent
Bro,
angles.
why is this one so faster than literally every single one that we looked?
It's not very big. Okay, so line 4 is what we're trying to prove, which I said earlier. They kind of left it as blank up there, but we're trying to prove the lines are parallel. Okay, why does angle 2 being congruent to angle 4 make the lines parallel? What are angle 2 and 4 in the picture?
Corresponding.
Right. You're kind of starting with the corresponding angles that are congruent. So corresponding angles are congruent. That's called the corresponding angle postulate, but let's just write it out.
What's the difference between postulate and theory? Like,
Okay, postulate is something you have to assume is true, it's not something you can prove. And theorems can be built on top of postulates. So by assuming corresponding angles are congruent lines are parallel, you can prove all these things also to be true.
okay.
So these three are actually theorems, that's the only postulate.
Oh.
Guys, I'm gruesome.
All right, go, go, go. Man, that took a long time, didn't it? Well, I did 2 with you guys, so all you have to do is 4 through 22.
Yeah.